Here we're going to look at question 7 from section 2 of the ENGAA specimen paper. So in this question we have two blocks, one of 4 kilograms and one of mass 6 kilograms. So they're both going to be connected by an inextensible string travelling over a pulley, which is at the top of an incline of 30 degrees. So when we look at our 4 kilogram mass, we're told that we have a 15 Newton force acting down the slope. Yet we also know that these two masses are going to be accelerating, which I've labelled as going in this direction here. So what the question asks us to do is to find the acceleration of our 4 kilogram mass, which is going to be exactly the same as our 6 kilogram mass, just since they're both connected by this string. Now if you would like to have a go at this question yourself, then please pause the video now. Otherwise, let's get on with it. So, since we're looking for the acceleration of our masses, we're probably going to have to deal with forces, especially since we've already got a force on here. So in that case, probably the best thing to do is try and label our diagram as much as possible with all the different forces which are going to be being experienced by our blocks. So let's start first of all with our 6 kilogram block. So there's just going to be two forces acting on this. We're going to have a tension acting in the upwards direction, and we're going to have a weight acting in the downwards direction, which is going to be 6g, 6 multiplied by the gravitational field strength. So now that we've got this, let's look at our 4 kilogram mass, which is going to be a bit more difficult, although not too much. So here we're going to have a force acting along the string again, which is just going to be the tension, and we're going to have this force due to weight, or 4g. Now this weight component here actually isn't too useful just as it is at the moment, because it's not really along the same direction as anything. We can't quite tell what direction it's in relative to these other directions. So what we can do is resolve it parallel to the slope. Now if we actually do this properly, then we find that the component which is parallel to the slope is just given by 4g sine of 30 degrees newtons. So we're also going to have this force acting down the slope in the same direction as our 15 newtons. Now with these are all the forces which I can really think of to try and label on our diagram, so we should probably go ahead and see if we can work out the accelerations from this. So how are we going to look for the accelerations? Well, the easiest thing to do is probably to use Newton's second law. Now we can do this on both of our masses, which we might as well do, and we'll see what we get from doing that. So if we start with our 6 kilogram mass, since it's a little bit simpler, then the resultant force is just going to be our 6g, our weight, minus the tension here, and that's going to be equal to the mass multiplied by the acceleration, just Newton's second law. So resultant force is equal to ma. Now if we do the same thing again for our 4 kilogram mass, then the resultant force is going to be equal to this tension, take away our 15 newtons and our 4g sine of 30 degrees. And that again is just going to be equal to the mass multiplied by the acceleration. So the resultant force equals ma. Now if we do want to look at these two equations, they're not actually too useful just yet, because while they've got an acceleration in them, which we want to find, they've both got a tension, which we don't know. So how could we get rid of that? Well, we could try and solve these equations simultaneously. So the easiest way of doing this is probably just to add the two equations together, in which case we'll get this. So tensions will cancel since one's negative and one's positive. And then we have this expression here, which isn't too bad really. We have a g in there, which we know is just going to be 10, and we have this sine of 30 degrees. So what's sine of 30 degrees? Well, it's just going to be a half. So that makes this equation a little bit nicer, and we can simplify it down by adding together our g terms with our minus 15 there. So taking g to be 10, as I said before, we get that 10 multiplied by the acceleration is just equal to 25, which we can divide by 10 to get the acceleration as being 2.5 meters per second squared, which is just going to correspond with answer B given in our question.